Right now, as you settle into your pillow and let your breathing slow, something truly enormous is sitting in the darkness at the center of our galaxy. It has no light, it makes no sound, and yet, without it, you would not exist. This invisible giant is called Sagittarius A star, and tonight, we are going to travel 26,000 light years to meet it together. If you enjoy these peaceful journeys through the cosmos, take a moment to tap that like button and subscribe to the Cosmic Drift channel. It helps more sleepy souls find their way here, and it means the world to us. Now, close your eyes if you would like, or let them rest gently on the ceiling above you. Imagine that the room around you is slowly fading away, replaced by the soft glow of distant stars. We are about to leave Earth behind, but not in any hurried way. This journey will be slow, calm, and filled with wonder. There is no rush when you are traveling to the heart of the Milky Way. Picture yourself floating just above the clouds of our planet. Below you, city lights twinkle like grounded constellations. Above you, the real stars begin to reveal themselves, first dozens, then hundreds, then thousands. The deeper you look into the night, the more the universe opens up to greet you. And somewhere far beyond those familiar points of light, past nebulae that glow like watercolor paintings, past star clusters that sparkle like spilled diamonds, there sits a quiet anchor holding everything together. Sagittarius. A star is not a star at all, despite its name. It is what astronomers call a supermassive black hole. But before any worry creeps into your mind, let me tell you something soothing. This black hole is not a monster lurking in the shadows, waiting to devour unsuspecting travelers. It is more like the still point at the center of a spinning top. Everything around it moves, dances, orbits, and swirls, but the black hole itself simply exists in patient silence. To understand why this matters, think about a merry-go-round at a playground. All the painted horses and benches spin around a central pole. Without that pole, there would be no merry-go-round at all. It would just be a collection of wooden horses scattered across the grass. Sagittarius A star is our galaxy's central pole. It is the reason the Milky Way exists as a spiraling disk of light rather than a chaotic cloud of stars drifting in every direction. Let that thought settle over you like a warm blanket. You are part of this spinning cosmic carousel. Every atom in your body is orbiting that distant point of darkness right now, moving through space at an almost unimaginable speed. And yet, you feel nothing but the softness of your bed and the gentle weight of relaxation spreading through your limbs. The journey to Sagittarius A star begins here, in the outer suburbs of our galaxy. We live in a quiet neighborhood, astronomically speaking. Our sun is just one ordinary yellow star among hundreds of billions in the Milky Way. It sits about 2/3 of the way out from the galactic center, tucked into a small spur of one of the spiral arms. This is a peaceful region of space, far from the crowded downtown where stars are packed so tightly together that the night sky would blaze with light. If you were standing on a planet near the galactic center, you would never experience true darkness. The stars there are so numerous and so close together that they create a permanent twilight, a soft glow that fills every corner of the sky. But here, in our cozy corner of the galaxy, we have the gift of darkness. We have the chance to look up and see the Milky Way stretching across the heavens like a river of light, hinting at the billions of suns that call this galaxy home. As we begin floating inward, the stars around us grow more numerous. What started as a scattered handful becomes a dense field, then a glittering fog. The fair space between stars shrinks. Colors emerge that we rarely see in our neighborhood. Ancient red giants swollen to enormous size. Blue supergiants burning so hot they could vaporize entire solar systems. White dwarfs no bigger than Earth, but with the mass of our sun compressed into their tiny frames. This is the inner galaxy, and it pulses with a kind of quiet energy, not chaotic or frightening, but alive in a way that feels almost musical. If the stars could sing, this region would sound like a symphony, each note blending into the next in a harmony that has been playing for billions of years. But where is the conductor of this cosmic orchestra? Where is the invisible hand guiding all these stellar performers? To find it, we must look past the light and into the darkness itself. The constellation Sagittarius, as seen from Earth, marks the direction of the galactic center. Ancient civilizations looked toward this patch of sky and saw an archer drawing his bow. They had no way of knowing that beyond those visible stars, beyond the glowing clouds of gas and dust, something remarkable was waiting to be discovered. For thousands of years, humanity gazed at Sagittarius without realizing they were looking toward the heart of their galactic home. The first hint that something unusual existed at the center of the Milky Way came in the early 20th century. Astronomers noticed that certain radio waves seemed to be coming from a specific point in the direction of Sagittarius. Radio waves are invisible to our eyes, but telescopes can detect them and translate them into data we can study. And this particular source of radio waves was puzzling. It was incredibly compact yet incredibly powerful, broadcasting a steady signal from a region of space that appeared completely empty in visible light. Scientists named this mysterious source Sagittarius A, using the letter to indicate it was the first major radio source discovered in that constellation. But as technology improved and observations became more precise, they realized that Sagittarius A was actually made up of multiple components. The brightest and most compact of these was given an asterisk after its name, a tiny symbol that would come to represent something truly massive. Sagittarius A star, or Esca A star as astronomers often abbreviate it, became the focus of intense study. What could produce such powerful radio emissions from such a small region of space? The answer, when it finally emerged after decades of careful observation, was both thrilling and humbling. Sagittarius. A star is a supermassive black hole containing roughly 4 million times the mass of our Sun, all compressed into a space smaller than the orbit of Mercury. This is the quiet giant at the center of our galaxy, the invisible anchor around which everything orbits. Let your mind rest with that number for a moment. 4 million suns. Every sunset you have ever watched, every warm ray of light that has touched your skin, all of that energy comes from just one sun. Now imagine 4 million of those. Their combined mass squeezed into a region you could not even see with your naked eye if you were floating nearby. It is a concentration of matter so extreme that even light cannot escape its gravitational pull. But here is the beautiful paradox that makes Sagittarius a star so peaceful to contemplate. Despite all that mass, despite all that gravitational power, the black hole at the center of our galaxy is remarkably quiet. It is not actively devouring stars or shooting jets of superheated matter across space like some of its more violent cousins in other galaxies. It is simply sitting there, holding everything in place with the gentle but firm hand of gravity. Think of it like a sleeping giant. It has the power to reshape the entire galaxy, but right now, in this particular era of cosmic history, it has chosen to rest. The stars that orbit close to it have found stable paths, dancing around the black hole in elegant ellipses that carry them perilously close before sweeping them back out to safer distances. These stellar orbits have been going on for millions of years, and they will continue for millions more. A cosmic ballet with no need for an encore because it never truly ends. As we drift closer to the galactic center, the darkness ahead begins to take on a different quality. It is not the empty darkness of open space where you can see stars in every direction. This is a deeper darkness, a region where light seems to curve and bend before disappearing entirely. We are approaching the event horizon, the boundary beyond which nothing can return. But do not let fear enter your heart. We are not going to cross that boundary. We are simply here to observe, to appreciate, to understand. From a safe distance, a supermassive black hole is not a threat. It is a marvel of nature, a place where the laws of physics are pushed to their absolute limits, where space and time themselves become twisted in ways that challenge our imagination. The event horizon of Sagittarius A is roughly the size of the orbit of Mercury around our Sun. If you could somehow place our entire solar system next to the black hole, the Sun and all its planets out to Mercury would fit inside the darkness. But beyond that point, everything would be safe. Earth would continue its orbit, and life would go on as if nothing unusual were nearby. Black holes are only dangerous if you get too close. From a reasonable distance, they are simply very, very heavy objects. What makes black holes so fascinating is not just their immense gravity, but what that gravity does to the fabric of space-time itself. According to Einstein's theory of general relativity, massive objects create curves in space-time, like a bowling ball sitting on a stretched rubber sheet. The more massive the object, the deeper the curve. A supermassive black hole creates a curve so deep and so steep that it becomes a kind of well from which nothing can climb out once it has fallen past a certain point. Imagine space-time as a calm pond, and the black hole as a drain at the bottom. Water flows toward the drain in gentle spirals, circling closer and closer, until it finally slips over the edge and disappears. The stars near Sagittarius A are like leaves floating on that pond, carried along by the currents of curved space-time, spiraling inward over millions of years, or maintaining stable orbits that keep them safely above the drain. Right now, several stars orbit very close to Sagittarius A. Astronomers have been watching these stars for decades, tracking their movements with incredible precision. One star, called S2, completes an orbit around the black hole in just 16 years. At its closest approach, S2 sweeps within about 100 astronomical units of Sagittarius A star, which is only about 3 times the distance from the Sun to Pluto. At that distance, the star is moving at roughly 3% the speed of light, over 20 million miles per hour, and yet it emerges unharmed, swinging back out into the relative safety of the inner galaxy. Watching S2 and its fellow stars dance around invisible nothing is one of the most beautiful confirmations we have that Sagittarius A truly exists. We cannot see the black hole directly because it produces no light. But we can see its effects on the matter around it, the way it bends the paths of stars, the way it heats the gas that drifts too close, the way it warps the very space through which light travels. This is how astronomy often works. We cannot always touch or see the things we study. We must infer their presence from the shadows they cast and the ripples they leave behind. Sagittarius. A star is the ultimate example of this principle. It is a darkness that reveals itself through the light of everything around it. Let that thought carry you deeper into relaxation. There is a certain comfort in knowing that the universe contains mysteries we can understand without fully seeing. Just as you cannot see the air you breathe or the dreams that will soon fill your sleeping mind, the black hole at the center of our galaxy remains hidden, while still making its presence known in profound ways. As we hover near the galactic center, take a moment to look around at the incredible scenery. The stars here are old, among the oldest in the Milky Way. Many of them formed more than 10 billion years ago, when the galaxy was still young and chaotic. They have survived the turbulent early days of galactic evolution, when collisions with other galaxies stirred up the cosmic neighborhood and sent waves of star formation rippling through the gas clouds. These ancient stars are like living fossils, carrying within their chemical signatures the history of the early universe. They contain fewer heavy elements than younger stars like our Sun, because heavy elements are created inside stars and scattered through space when those stars die. The first generation of stars had only hydrogen and helium to work with, the simplest ingredients in the cosmic recipe book. Over billions of years, successive generations of stars have enriched the galaxy with heavier elements, building up the periodic table one supernova at a time. You are made of those heavy elements. The carbon in your cells, the calcium in your bones, the iron in your blood, all of it was forged inside ancient stars that lived and died long before our Sun was born. And all of those stars, every single one that contributed to your existence, orbited the same supermassive black hole that we are visiting tonight. Sagittarius. A star has been the silent witness to billions of years of cosmic evolution, watching as stars were born, lived their lives, and scattered their ashes to create new worlds and new forms of life. This is perhaps the most profound aspect of our relationship with the galactic center. We are connected to it, not just through gravity, but through the deep history of matter itself. The atoms in your body have been circling Sagittarius A star for billions of years, passed from generation to generation of stars, assembled into planets and oceans, and eventually into living beings who can look up at the night sky and wonder about their place in the cosmos. Let that connection fill you with a sense of belonging. You are not a stranger in this universe. You are a child of the Milky Way, born from the same primordial hydrogen that formed the first stars, shaped by the same gravitational forces that organized matter into galaxies, and held in place by the same supermassive black hole that anchors everything we see in our night sky. The black hole does not know you exist, of course. It has no consciousness, no awareness, no thoughts of any kind. It is simply an extremely dense collection of matter wrapped in curved spacetime. But there is something beautiful about that impersonal connection, a reminder that the universe operates on scales so vast that human concerns become wonderfully small. Whatever worries have followed you into bed tonight, whatever anxious thoughts have been circling your mind like restless moths around a lamp, consider them now in the context of Sagittarius A star. The problems that seem so large and pressing in your daily life are happening on a single planet, orbiting a single star, in the outer suburbs of a single galaxy, all of which is spinning around a point of darkness 26,000 light-years away. Your troubles are real, and they matter to you, but they are also tiny ripples in an ocean so vast that even our most powerful telescopes can barely glimpse its shores. This is not meant to diminish your experiences. It is meant to give you perspective, the kind of cosmic perspective that can ease anxiety and promote peaceful sleep. The universe has been here for nearly 14 billion years. It will continue for billions more. Whatever you are facing, It is a temporary chapter in an eternal story, and the black hole at the center of our galaxy will keep spinning long after your chapter has closed and new chapters have begun. Now, as we continue our journey, let us explore how astronomers first confirmed the existence of Sagittarius A star. The story involves patience, brilliant thinking, and some of the most sophisticated instruments ever built by human hands. For most of the human history, the center of our galaxy was hidden from view. Dense clouds of gas and dust lie between Earth and the galactic core, blocking visible light like a cosmic curtain. When you look at the Milky Way on a clear summer night, you might notice that the bright band of stars seems to bulge in the direction of Sagittarius, hinting at the concentration of matter toward the center. But the actual core remains invisible, shrouded in a veil that visible light cannot penetrate. Radio waves and infrared light, however, can pass through this dusty barrier. These longer wavelengths slip between the particles of dust, like water flowing through a net, allowing astronomers to peer into regions that would otherwise remain forever hidden. When radio telescopes first turned their attention to the galactic center in the mid-20th century, they discovered a wonderland of activity, hot gas clouds, magnetic fields, and that curious compact source known as Sagittarius A star. But detecting radio waves from a specific location is not the same as proving a supermassive black hole exists there. To make that case, astronomers needed to measure the mass of whatever object was producing those signals. And the only way to measure mass from such a great distance is to watch how it affects the motion of nearby objects. Enter the stars, specifically a handful of stars orbiting very close to Sagittarius A star. These stars are moving so fast and orbiting so tightly that by tracking their paths over time, astronomers can calculate the mass of the object they are orbiting. It is the same principle that allows scientists to calculate the mass of planets by watching how quickly their moons orbit around them. Starting in the 1990s, two independent research teams began the painstaking work of tracking stars near the galactic center. One team was led by Andrea Ghez at UCLA, and the other by Reinhard Genzel at the Max Planck Institute in Germany. Both teams used infrared telescopes equipped with adaptive optics, technology that corrects for the blurring effects of Earth's atmosphere in real time, allowing them to see details that would otherwise be smeared into a fuzzy blob. Year after year, the teams gathered images of the galactic center, measuring the positions of stars with incredible precision. Slowly, the orbital paths began to emerge. One star would complete a partial arc, then more of its path would be revealed, then finally the full orbit would become clear. It was like watching a mystery unfold in extreme slow motion, each new data point adding another piece to the puzzle. The results were astonishing. The stars near Sagittarius A star are moving faster than any other stars in the galaxy, reaching speeds that would be impossible unless something incredibly massive was pulling on them. And that massive object is contained within a region smaller than our solar system. When you combine enormous mass with tiny volume, there is only one known explanation: a black hole. In 2020, Andrea Ghez and Reinhard Genzel shared the Nobel Prize in Physics for their work confirming the existence of a supermassive black hole at the center of the Milky Way. It was a recognition not just of their scientific achievement, but of the decades of patient observation that made it possible. The universe does not reveal its secrets quickly. It requires time, dedication, and the willingness to stare into the darkness year after year, waiting for the light of understanding to emerge. This Nobel Prize-winning discovery is something you can carry with you into sleep. The knowledge that human beings, curious and determined, have managed to prove the existence of an invisible giant 26,000 light-years away. We cannot travel there in our lifetimes. We cannot touch it or see it with our naked eyes. But we know it is there, and we understand something profound about its nature. That is a remarkable accomplishment for a species that has only been doing science for a few hundred years. As you feel your body growing heavier and your thoughts beginning to drift, let us talk about what happens to matter that gets too close to Sagittarius A. This is not meant to frighten you, but rather to inspire awe at the extreme conditions that exist near supermassive black holes. When gas or dust drifts too close to the black hole, it does not simply fall straight in. Instead, it swirls into a flattened disk, heated by friction to temperatures of millions of degrees. This is called an accretion disk, and in more active black holes, it can produce blinding light and powerful jets of energy that shoot across millions of light years. But Sagittarius A is currently on a cosmic diet. There is not much material falling into it, which is why it remains relatively quiet and dim. Occasionally, however, something does wander too close. Astronomers have observed flares of X-ray and infrared light from the vicinity of Sagittarius A, brief brightenings that suggest material is being heated and torn apart before disappearing beyond the event horizon. These flares are like cosmic burps, small releases of energy compared to what more active black holes produce, but still powerful enough to be detected from 26,000 light-years away. In 2014, astronomers watched with great excitement as a gas cloud called G2 approached Sagittarius A on a trajectory that seemed destined to plunge it directly into the black hole. They expected fireworks, a dramatic brightening as the gas was heated and consumed, but the show was less spectacular than anticipated. G2 survived its close encounter, stretched and distorted by tidal forces, but not completely destroyed. It turned out to be denser than expected, perhaps a star surrounded by a shroud of gas, rather than just a lonely cloud. This kind of uncertainty is part of what makes astronomy so exciting. Even with our most advanced instruments, the universe still surprises us. We think we understand how something will behave, and then reality reveals a twist we did not anticipate. Sagittarius, a star, remains full of mysteries, a subject for future generations of scientists to explore with technologies we cannot yet imagine. But for tonight, let us focus on what we do know. We know that a supermassive black hole sits at the center of our galaxy. We know its mass, roughly 4 million times the mass of our Sun. We know the orbits of dozens of stars that circle around it, some in tight, fast paths and others in wide, slow arcs. We know that it is currently quiet, not actively consuming large amounts of matter, and we know that it has been there for billions of years shaping the galaxy we call home. This knowledge is itself a kind of comfort. In a universe that can feel random and chaotic, there is order at the center. The Milky Way is not a collection of stars drifting aimlessly through space. It is a structured, organized system, bound together by gravity and anchored by a supermassive black hole that has been holding its position for longer than Earth has existed. Let that stability ease your mind. The galaxy is not falling apart. The stars are not scattering into the void. Everything is orbiting, circling, spinning in patterns that have been established for billions of years and will continue for billions more. You are part of that cosmic dance, even if your contribution is too small to detect. Every atom in your body is moving through space, carried along by the rotation of the Milky Way, held in place by the distant gravity of Sagittarius A. Now, let us zoom out a bit and consider what Sagittarius A star looks like from a wider perspective. If we could somehow rise above the plane of the Milky Way and look down on our galaxy from the outside, what would we see? The Milky Way is a spiral galaxy, one of the most common types in the universe. It has a central bulge of older stars surrounding the galactic core, and from this bulge, graceful arms spiral outward into space, trailing clouds of gas and dust and younger stars. Our Sun is located in one of these spiral arms, which means we have a sideways view of the galaxy when we look up at the night sky. That glowing band of light stretching from horizon to horizon is the combined light of billions of stars, all lying in the thin disk of the galactic plane. From above, the spiral arms would be clearly visible, sweeping out from the central bulge like the arms of a pinwheel. And at the very center of that pinwheel, invisible but present, would be Sagittarius A star. It is the hub around which everything turns, the fixed point in a spinning galaxy of light. Spiral galaxies like the Milky Way are incredibly beautiful, and astronomers have observed millions of them in other parts of the universe. Each one has its own supermassive black hole at the center, ranging in mass from a few million to several billion times the mass of our Sun. The relationship between galaxies and their central black holes is one of the most interesting areas of research in modern astrophysics. It seems that the two grow together, with the black hole gaining mass as the galaxy evolves, locked in a cosmic partnership that spans billions of years. How does a supermassive black hole form in the first place? This is a question that astronomers are still working to answer, and the truth is that we are not entirely sure. One possibility is that they start as smaller black holes, the remnants of massive stars that explode at the end of their lives, and then grow by swallowing gas and merging with other black holes over time. Another possibility is that they form directly from giant clouds of gas in the early universe, collapsing straight into black hole-sized objects without passing through a stellar phase at all. Whatever their origin, supermassive black holes seem to be a fundamental feature of large galaxies. Every time astronomers look at the center of a major galaxy, they find evidence of a supermassive black hole lurking there. The Milky Way is no exception, and Sagittarius A star is our particular version of this universal phenomenon. There is something reassuring about that universality. Wherever you look in the cosmos, the same laws of physics apply. The same gravitational forces that hold you to your bed are holding Sagittarius A, star at the center of our galaxy, and holding trillions of other black holes at the centers of trillions of other galaxies scattered across the observable universe. The universe may be vast and strange, but it is also consistent. The same rules apply everywhere, from the smallest atom to the largest supercluster of galaxies. This consistency is what makes science possible. If the universe were truly random, if different rules applied in different places, we would have no hope of understanding anything beyond our immediate surroundings. But because the laws of physics are the same everywhere, we can study Sagittarius A star from Earth and be confident that our conclusions apply. We can observe distant galaxies and know that their central black holes behave according to the same principles as our own. Let that universal consistency be another source of peace as you drift towards sleep. You are not living in a chaotic or unpredictable universe. You are living in a cosmos that follows rules, that has structure and order, that can be understood by patient observation and careful thought. The same gravity that keeps you in bed is keeping the stars in their orbits and the black hole in its place. Everything is connected, governed by elegant mathematical relationships that have been operating since the very beginning of time. Speaking of time, let us consider how long Sagittarius A star has been at the center of our galaxy. The Milky Way itself is roughly 13 billion years old, making it nearly as ancient as the universe itself. It did not always look the way it does today. In its early days, the galaxy was smaller and more chaotic, absorbing smaller galaxies and accumulating mass through billions of years of cosmic mergers. Throughout all of this, Sagittarius A star has been growing and evolving alongside its host galaxy. When the Milky Way was young, the black hole was probably smaller and more active, feeding on the abundant gas that filled the early universe. As the galaxy matured and the supply of available gas decreased, the black hole settled into the quiet state we observe today. But the relationship between galaxy and black hole has always been intimate, each influencing the evolution of the other in ways that astronomers are still working to fully understand. It is strange to think that the black hole at the center of our galaxy has witnessed the entire history of the Milky Way. It was there when the first stars ignited, flooding the cosmos with light for the first time. It was there when the first heavy elements were forged and scattered across space. It was there when our sun formed from a cloud of enriched gas, and when Earth coalesced from the debris left over after the sun's birth. It was there when life first appeared in our oceans, and when the first creatures crawled onto land. It has been there through every human civilization, every war, every work of art, every scientific discovery, silent and unchanging at the center of it all. That perspective can make human history feel very small, but it can also make it feel very precious. Out of all the trillions of stars in this galaxy, ours produced a planet where life could thrive and eventually become aware of its own cosmic context. We are the Milky Way's way of knowing itself, the universe looking back at its own structure and marveling at what it sees. Sagittarius A star has been waiting at the galactic center for 13 billion years, and now, for the first time, beings from one of its orbiting stars are capable of understanding what it is. You are part of that understanding. By learning about Sagittarius A star, by contemplating its nature as you drift towards sleep, you are participating in one of the greatest achievements of human civilization. You are taking your place in a long tradition of stargazers and scientists who have looked up at the night sky and asked questions about what they see. You are connected not just to the black hole at the center of the galaxy, but to every human being who has ever wondered about the cosmos. Let that connection bring you peace. You are not alone in your curiosity. You are not alone in your desire to understand. You are part of a species that has been asking questions about the universe for as long as we have existed, and those questions have led us to discoveries that would have seemed like magic to our ancestors. The black hole at the center of our galaxy is no longer a mystery. It is a known feature of our cosmic neighborhood, mapped and measured by human ingenuity. As we continue our journey tonight, let us spend some time appreciating the stars that orbit closest to Sagittarius A star. These are some of the most extreme stars in the galaxy, living lives that would be impossible anywhere else. The star called S2, which we mentioned earlier, is perhaps the most famous of these inner orbit stars. It is a young, massive star, burning hot and blue, about 15 times the mass of our Sun. S2 completes its orbit around Sagittarius A star every 16 years, coming within about 17 light hours of the black hole at its closest approach. That is incredibly close by astronomical standards, closer than any other star known to orbit our central black hole. When S2 swings through its closest approach, it experiences conditions that would be unimaginable elsewhere in the galaxy. The gravitational pull is so intense that time itself slows down relative to the rest of the universe, a consequence of Einstein's general relativity. The star is also subjected to tidal forces that try to stretch it toward the black hole, though S2 is massive enough to resist being torn apart. Astronomers have used observations of S2 to test Einstein's predictions about gravity in the most extreme conditions. So far, general relativity has passed every test with flying colors. The star's orbit curves exactly as Einstein said it would, including a subtle precession that causes the orbit to rotate over time. These measurements are some of the most precise tests of gravitational theory ever conducted, and they confirm that our understanding of physics holds even at the edge of a supermassive black hole. There are other stars in the inner region as well, each with its own orbit and its own story. Some are even closer to the black hole than S2, though they are fainter and harder to observe. Astronomers have identified dozens of these S-stars, as they are collectively known, and each one provides another data point for understanding the gravitational environment near Sagittarius A. Imagine being on a planet orbiting one of these stars, looking up at a sky dominated by the swirling chaos of the galactic center. The view would be nothing like what we see from Earth. Instead of a peaceful scattering of stars against a dark backdrop, you would see a blazing wall of light. Hundreds of thousands of stars packed so tightly together that individual points would be hard to distinguish. And somewhere in that light, invisible but ever present, the black hole would be lurking, shaping every orbit and bending every beam of light that passed too close. Life on such a planet seems unlikely. The radiation environment would be harsh, the gravitational disturbances would be constant, and the very fabric of space-time would be twisted in ways that might make stable chemistry impossible. But who knows what forms life might take in conditions we cannot imagine. The universe has surprised us before, and it will surely surprise us again. For now, let us be grateful that we live in a quieter part of the galaxy, where the nights are dark and the stars are distant enough to be counted. Our position in the outer suburbs of the Milky Way is actually ideal for the development of intelligent life, far enough from the galactic center to avoid the intense radiation and gravitational disruptions, but still part of the grand cosmic dance that connects everything in the galaxy. You are in exactly the right place, at exactly the right time, to be contemplating these ideas. The universe has arranged itself in such a way that beings like you can exist, can wonder, can learn. That is not something to take for granted. It is a gift, a cosmic accident of staggering improbability, and every moment of awareness is an opportunity to appreciate it. As your breathing deepens and your muscles relax, let us talk about something that might seem impossible. How do you weigh something that produces no light and sits 26,000 light years away? This is one of the cleverest tricks in all of astronomy, and it relies on nothing more than careful observation and the beautiful mathematics of orbital mechanics. When two objects orbit each other, the speed of their orbit depends on the combined mass of both objects and the distance between them. If you know the orbital speed and the distance, you can calculate the mass. This is how we know the mass of the Sun, by measuring how fast Earth orbits around it. And it is how we know the mass of Sagittarius A, by measuring how fast the nearby stars orbit around it. The calculation is elegant in its simplicity. You watch a star like S2 over the course of its 16-year orbit. You measure exactly how long it takes to complete one revolution and how close it gets to the central object at its nearest approach. You plug those numbers into Newton's laws of motion, and out pops the mass. 4 million times the mass of our Sun, give or take a few 100,000. The precision of these measurements has improved dramatically over the decades. Early estimates had large uncertainties because the stars were hard to track and the distances were difficult to measure. But with modern adaptive optics and decades of accumulated data, astronomers can now measure the mass of Sagittarius A star to within a few percent. That is an astonishing level of accuracy for an object we cannot see, located at such an immense distance. This kind of indirect measurement is common in astronomy. We rarely get to touch or directly observe the objects we study. Instead, we infer their properties from the light they emit, the gravitational effects they produce, or the shadows they cast. Sagittarius A star is perhaps the ultimate example of this approach, a massive object known only through the dance of the stars that orbit around it. There is something almost poetic about that. The black hole reveals itself not through its own actions, but through the behavior of everything around it. It is like knowing someone exists because you can see the effects they have on their friends and family, the way people move differently when they are nearby, the subtle changes in the social gravity of a room. Sagittarius, a star, is the most influential presence in our galaxy, and yet it remains forever silent and invisible. As you settle deeper into relaxation, let us consider what would happen if you could somehow travel to Sagittarius A star and approach the event horizon. This is purely a thought experiment, of course. No spacecraft we could build would survive the journey, and no human body could withstand the conditions near a supermassive black hole. But in imagination, we can go anywhere, and tonight we are going to the edge of darkness. As you approach the black hole, the first thing you would notice is the distortion of starlight around you. The intense gravity bends light that passes nearby, creating a phenomenon called gravitational lensing. Stars that should be behind the black hole would appear smeared and stretched into arcs of light, their images warped by the curved space-time. The closer you get, the more extreme this distortion becomes, until the entire universe seems to be stretching and twisting around you. At a certain distance, you would see something remarkable. A bright ring of light encircling the black hole, created by photons that have been bent just enough to orbit the black hole before escaping toward your eyes. This is called the photon sphere, and it marks the boundary where light itself becomes trapped in orbit. Inside the photon sphere, even light must spiral inward, unable to escape the gravitational pull. The event horizon itself would appear as a perfect circle of darkness, a void in the fabric of space where no light can emerge. If you were close enough, you might see the silhouette of the black hole against the brilliant background of the galactic center, a dark disk surrounded by a glowing ring of superheated gas and distorted starlight. This is almost exactly what the Event Horizon Telescope captured in its famous image of the supermassive black hole in the galaxy M87, a cosmic portrait that confirmed decades of theoretical predictions. But Sagittarius A star is much smaller than the black hole in M87, and the view would be correspondingly different. The accretion disk, if any existed, would be fainter and less dramatic. The photon sphere would be smaller. But the essential features would be the same, a region of absolute darkness surrounded by a halo of light that has been bent and warped by the most extreme gravitational field in the galaxy. If you continued falling toward the event horizon, something strange would happen to your perception of time. According to general relativity, time passes more slowly in strong gravitational fields. The closer you get to the black hole, the slower your clock would tick relative to someone watching from a safe distance. If you could somehow hover just above the event horizon and look back at the universe, you would see time racing forward, stars being born and dying, galaxies evolving, billions of years passing in what feels like moments. This time, dilation is not science fiction. It is a real, measured phenomenon. Clocks on GPS satellites run slightly faster than clocks on the ground because they are farther from Earth's gravitational field. The effect is tiny in our everyday experience, but near a supermassive black hole, it would be dramatic and unmistakable. At the event horizon itself, time would seem to stop entirely from the perspective of an outside observer. If you were watching a friend fall into the black hole, you would see them slow down as they approach the boundary, their image becoming redder and dimmer as the light they emit is stretched by the expanding spacetime. They would never quite cross the horizon from your point of view, their final image frozen in time at the edge of darkness. From your friend's perspective, however, the crossing would be uneventful. They would not even notice the moment they pass the event horizon, because locally, nothing special happens there. The event horizon is not a physical barrier, just a mathematical boundary beyond which escape becomes impossible. It is only later, when they are deep inside the black hole and being torn apart by tidal forces, that they would realize something had gone terribly wrong. This asymmetry between the observer and the falling object is one of the strangest consequences of general relativity, and it highlights how different space-time can be in extreme gravitational environments. Near Sagittarius A, the familiar rules that govern our everyday experience break down, replaced by a geometry of curved space and stretched time that challenges our intuition at every turn. But you do not need to worry about any of this tonight. You are safe in your bed, 26,000 light years from the nearest supermassive black hole, surrounded by the gentle gravity of Earth and the peaceful darkness of your room. The strange physics of black holes is a subject for daytime contemplation, when your mind is sharp and your curiosity is at its peak. Right now, the only curves you need to think about are the soft curves of your pillow and the gentle arc of your spine as you settle into sleep. Let us return to the broader picture of our galaxy and consider how Sagittarius A star fits into the larger cosmic story. The Milky Way is not alone in the universe. It is just one of hundreds of billions of galaxies scattered across the observable cosmos, each one a separate island of stars orbiting its own supermassive black hole. Some of these galaxies are much larger than ours, with black holes containing billions of times the mass of our Sun. Others are tiny dwarf galaxies with black holes that might weigh only a few 100,000 solar masses. The diversity is astonishing. A cosmic zoo of galactic shapes and sizes, each one unique but all following the same basic principles of gravity and stellar evolution. The Milky Way belongs to a small cluster of galaxies called the Local Group. Our nearest large neighbor is the Andromeda Galaxy, a spiral galaxy slightly larger than our own. Located about 2.5 million light-years away, Andromeda has its own supermassive black hole at its center, estimated to be around 100 million times the mass of our Sun, more than 20 times larger than Sagittarius A star. In about 4 to 5 billion years, the Milky Way and Andromeda will collide. This sounds catastrophic, but in reality, galaxy collisions are surprisingly gentle events. The stars in each galaxy are so far apart that direct collisions between stars are extremely rare. Instead, the two galaxies will pass through each other, their structures disrupted by gravitational tides, but their individual stars largely unharmed. Over hundreds of millions of years, the two galaxies will fall back together, merge, and eventually settle into a single larger galaxy that astronomers have nicknamed Milkdromeda. And at the center of this new galaxy, the two supermassive black holes will begin their own slow dance, spiraling toward each other until they eventually merge into a single, even more massive black hole. When black holes merge, they release enormous amounts of energy in the form of gravitational waves, ripples in spacetime that spread outward at the speed of light. In 2015, scientists detected gravitational waves for the first time, opening a new window onto the universe and confirming another prediction of Einstein's general relativity. The mergers that have been detected so far involve smaller black holes, the remnants of dead stars, but future detectors may be sensitive enough to detect the merger of supermassive black holes, including the eventual union of Sagittarius A star and its Andromeda counterpart. This future is so distant that it is almost beyond comprehension. 5 billion years from now, our sun will have exhausted its nuclear fuel and expanded into a red giant, likely engulfing Earth in the process. Any descendants of humanity, if they still exist, will have long since left our solar system for other homes among the stars. The merger of the Milky Way and Andromeda will be witnessed by whatever beings happen to be alive at that time, if any. But the story of Sagittarius A star will continue. The black hole does not care about the fate of individual stars or the rise and fall of civilizations. It simply exists, gathering mass over cosmic timescales, anchoring whatever galaxy happens to form around it. In that sense, the black hole is the most permanent resident of our cosmic neighborhood, a fixture that will outlast everything we know. Let that permanence be a source of comfort as you drift towards sleep. In a universe where everything changes, where stars are born and die, and galaxies collide and reform, the black hole at the center remains a constant. It has been there since the beginning of the Milky Way, and it will be there at the end, a silent witness to the entire history of our galactic home. Now, let us talk about something that might surprise you. Despite being called a black hole, Sagittarius A star is not completely dark. It does not emit light in the traditional sense, but the material falling toward it does, and occasionally dramatic events occur that produce brief but brilliant flashes of radiation. In 2019, astronomers observed a sudden brightening near Sagittarius A star, a flare of infrared light that made the region around the black hole 75 times brighter than normal. The cause was probably a cloud of gas or a small star that wandered too close and was heated to extreme temperatures as it fell toward the event horizon. The flare lasted only a few hours before fading back to normal levels, a brief cosmic firework in the otherwise quiet galactic center. These flares are reminders that even a quiet black hole like Sagittarius A star is not entirely inactive. It is still slowly consuming matter, still influencing the environment around it, still capable of producing dramatic events when something strays too close. The galaxy's central engine is idling, but it could roar to life at any moment if the right fuel were provided. In the distant past, Sagittarius A star may have been much more active. Many galaxies in the early universe hosted active galactic nuclei, brilliant beacons of light powered by black holes devouring matter at prodigious rates. Our own black hole may have gone through similar phases, blazing with the light of 1,000,000,000,000 suns before settling into its current quiet state. The evidence for this active past is written in the structures surrounding the galactic center, bubbles and filaments of hot gas that suggest powerful outbursts in the not-too-distant cosmic past. But for now, and for the foreseeable future, Sagittarius, a star, will remain the quiet giant we have come to know. It will continue to anchor our galaxy, holding the stars in their orbits and maintaining the spiral structure that makes the Milky Way so beautiful. It will continue to bend light and warp spacetime, creating the strange geometric environment that challenges our understanding of physics. And it will continue to inspire curiosity in beings like you, who look up at the stars and wonder about the universe they inhabit. As your eyelids grow heavy and your thoughts begin to scatter like stars in the night sky, let us spend a moment appreciating the sheer scale of everything we have discussed. Sagittarius, a star, contains 4 million times the mass of our Sun, compressed into a region smaller than our solar system. The event horizon spans about 15 million miles, smaller than the orbit of Mercury, but containing more matter than millions of stellar systems combined. Around this central point, billions of stars orbit at various distances, from the tight, fast spirals of the S stars to the wide, slow arcs of stars like our Sun in the galactic suburbs. The entire disk of the Milky Way spans about 100,000 light-years, a flat pancake of stars and gas and dust, rotating around the center like a cosmic phonograph record. And at the very center of this record, like the spindle that holds everything in place, sits Sagittarius, a star. If you could somehow shrink the Milky Way to the size of a dinner plate, Sagittarius, a star, would be smaller than an atom at the center. And yet, that tiny point contains more gravitational influence than anything else in the galaxy. It is the ultimate example of small but mighty, a cosmic lesson in how concentrated power can shape entire systems. This principle applies beyond astronomy as well. In your own life, small things often have outsized effects. A kind word at the right moment can change someone's entire day. A single decision can set in motion a chain of events that transforms your future. The universe is built on these kinds of leverage points, places where a little bit of something creates enormous effects elsewhere. Sagittarius. A star is the ultimate leverage point for our galaxy. Without it, the Milky Way would not exist in its current form. The stars would scatter, the spiral arms would dissolve, and the beautiful structure we see in images of our galaxy would be lost. Everything depends on that one point of darkness at the center, holding it all together through the invisible force of gravity. Let that thought settle over you like a warm blanket. You are part of a system that is held together, organized, structured. You are not drifting alone through a chaotic void. You are orbiting, along with everything else in the Milky Way, around a common center. You belong to this galaxy, and this galaxy belongs to you. The journey we have taken tonight has covered 26,000 light-years, from your bed to the heart of the Milky Way and back again. We have explored the nature of supermassive black holes, the orbits of stars in extreme environments, the history of scientific discovery, and the future of galactic evolution. We have touched on Einstein's relativity, gravitational waves, and the strange geometry of curved spacetime. And through it all, we have maintained a sense of peace and wonder, approaching these grand cosmic topics with the calm curiosity of someone settling in for a good night's sleep. Sagittarius, a star will still be there when you wake up tomorrow. It will be there next week, next year, and for billions of years to come. It is the most patient object in the galaxy, content to sit in darkness and let everything else orbit around it. You can visit it in your imagination whenever you like, returning to the galactic center as often as you need to find perspective and peace. But for now, it is time to let the black hole fade into the background and focus on the gentle darkness of your own room. The stars outside your window are all orbiting Sagittarius A star, whether they know it or not. The atoms in your body are part of the same cosmic dance, circling the galactic center along with everything else. You are connected to the universe in ways that go far beyond what your senses can detect, tied to the grand structure of reality by invisible threads of gravity and history. Let us continue our exploration by considering one of the most mind-bending aspects of black holes. What happens to information that falls past the event horizon? This question has puzzled physicists for decades and touches on some of the deepest mysteries in our understanding of the universe. According to quantum mechanics, information can never be truly destroyed. Every particle carries a history, a record of every interaction it has ever had, encoded in its quantum state. This principle is fundamental to how the universe works at the smallest scales, and violating it would upend our understanding of physics. But black holes seem to destroy information. When matter falls past the event horizon, it is cut off from the outside universe forever. The information it carried seems to be lost, trapped behind a boundary from which nothing can escape. For many years, this appeared to be a contradiction, a place where two pillars of modern physics, general relativity and quantum mechanics, came into direct conflict. Stephen Hawking made the problem even more puzzling in the 1970s, when he showed that black holes are not completely black after all. Through a subtle quantum process, black holes slowly emit radiation, losing mass over incredibly long timescales until they eventually evaporate completely. This Hawking radiation, as it came to be called, appears to carry no information about what fell into the black hole, suggesting that when the black hole finally evaporates, all the information it consumed is truly and permanently gone. This became known as the black hole information paradox, and it sparked decades of heated debate among physicists. Some argued that information really is destroyed, and we need to revise our understanding of quantum mechanics. Others argued that the information is somehow preserved, encoded in subtle correlations within the Hawking radiation, or stored in some exotic structure at the event horizon. The current scientific consensus leans toward information being preserved, though the exact mechanism remains unclear. Recent work, involving ideas from string theory and quantum gravity, suggests that black holes may be more complicated than they first appear, with the event horizon acting not as a simple boundary, but as a complex quantum system that somehow keeps track of everything that has fallen in. For Sagittarius A star, these questions are mostly theoretical. The black hole is so massive that its Hawking radiation is completely negligible, far too faint to ever detect. It will not evaporate for countless trillions of years, long after the last stars have burned out and the universe has grown cold and dark. But the questions it raises about the nature of information, reality, and the fundamental laws of physics are some of the most profound in all of science. You do not need to solve these puzzles tonight. You do not need to understand quantum mechanics or general relativity to appreciate the wonder of what we have discussed. It is enough to know that the universe contains mysteries we have not yet solved, questions that challenge the brightest minds and inspire ongoing research. The black hole at the center of our galaxy is not just an astronomical object. It is a portal to deeper understanding, a place where the known shades into the unknown and the unknown beckons us forward. Let that sense of mystery accompany you into sleep. The universe is not a closed book. It is a story still being written, with new chapters waiting to be discovered by future generations. The questions we cannot answer today will eventually yield to new insights and new technologies, just as the questions of past centuries have yielded to the science of our time. As you feel yourself sinking deeper into relaxation, let us return to the simple beauty of our galaxy and the quiet giant at its center. The Milky Way is your home, the island of stars that gave birth to your sun, your planet, and you. Everything you have ever known exists within this galaxy, from the first moments of your life to the last thought you will ever think. You are a Milky Way native, born and raised in the suburbs of a spiral galaxy, orbiting a supermassive black hole that has been holding everything together for billions of years. This is your cosmic address. Not just Earth, not just the solar system, but the Milky Way galaxy, orbiting Sagittarius A star, along with hundreds of billions of other stars. When astronomers in distant galaxies look toward our little corner of the universe, they see the combined light of all those stars, a faint smudge in their telescopes that reveals nothing about the individual lives being lived here. But to us, this galaxy is home, and Sagittarius A star is the anchor that keeps our home in place. The feeling of belonging is one of the most powerful emotions humans can experience. We are social creatures, evolved to seek connection with others, to find our place within groups and communities. But belonging extends beyond human relationships. You also belong to this planet, to this solar system, to this galaxy. You are part of something much larger than yourself, connected to cosmic structures that dwarf anything human beings have ever built. When you feel alone or disconnected, remember Sagittarius A star. Remember that you are orbiting the same center as every other star in the Milky Way, moving through space on a journey that began billions of years before you were born and will continue billions of years after you are gone. You are a temporary passenger on a cosmic voyage, but the voyage itself is eternal, and your presence on it matters simply because it exists. Let us now explore the region around Sagittarius A star in more detail, visiting some of the remarkable structures that exist near the galactic center. This is one of the most dynamic and visually stunning parts of our galaxy, filled with features that would be impossible anywhere else. One of the most striking structures near the galactic center is called the circumnuclear disk. This is a ring of gas and dust orbiting Sagittarius A star at a distance of a few light years, slowly spiraling inward over millions of years. The disk is not smooth but clumpy, with dense clouds of molecular gas separated by regions of hotter, more diffuse material. Stars are actively forming in some of these clouds, new suns being born in the shadow of the supermassive black hole. The circumnuclear disk is interesting because it represents the fuel supply for Sagittarius A star. As gas from this disk drifts inward and crosses the event horizon, the black hole gains mass and briefly produces radiation. The current low activity level of the black hole suggests that not much material is currently making its way inward, but that could change. If a large cloud of gas were to fall toward the center, Sagittarius A star could briefly awaken, producing flares and outbursts that would be visible from across the galaxy. Beyond the circumnuclear disk lies a larger structure called the central molecular zone. This is a vast region of dense molecular gas spanning several hundred light years around the galactic center. the central molecular zone contains enough raw material to form millions of new stars, and indeed, star formation is occurring throughout this region, though at a surprisingly low rate given the available fuel. The mystery of why star formation is so sluggish in the central molecular zone is one of the open questions in galactic astronomy. By all rights, with so much dense gas compressed into such a small region, stars should be forming at a furious rate. But something is suppressing the process. Perhaps the intense magnetic fields that thread through the region. Perhaps the turbulent motions stirred up by the nearby supermassive black hole. Perhaps some combination of factors we have not yet identified. As you continue to relax, let your mind wander through these cosmic clouds, imagining the countless potential stars waiting to be born. Each one of those clouds contains the raw ingredients for solar systems, for planets, perhaps for life. The future history of the inner galaxy is hidden in those clouds, waiting to unfold over millions of years of cosmic evolution. Within the central molecular zone, astronomers have also discovered several peculiar structures that defy easy explanation. There are long filaments of ionized gas stretching across the sky, apparently aligned with the galaxy's magnetic field. There are mysterious radio sources that come and go, flickering like cosmic fireflies. And there are hints of past explosive events, bubbles and shells of hot gas that suggest Sagittarius A was much more active in the relatively recent past. Two enormous bubbles of hot gas extend above and below the plane of the Milky Way, centered on the galactic nucleus. These Fermi bubbles, as they are called, span 50,000 light-years from tip to tip, a pair of gigantic lobes billowing out from the center of our galaxy like the plumes of an erupting volcano. They were discovered in 2010 by the Fermi Gamma-Ray Space Telescope, and their origin remains a subject of active research. The most likely explanation for the Fermi bubbles is that they were created by past activity from Sagittarius A. Perhaps the black hole went through a period of active feeding millions of years ago, producing powerful jets of energy that inflated these enormous structures. Or perhaps a burst of star formation near the galactic center triggered a series of supernovae that collectively blew out these bubbles. Either way, they are a reminder that the galactic center is not as quiet as it currently appears. If you could look at the Milky Way from the outside, the Fermi bubbles would be quite prominent, a pair of glowing orbs flanking the central bulge of stars. They are invisible to our naked eyes because they emit primarily gamma rays and X-rays, high-energy forms of radiation that our atmosphere blocks. But with the right telescopes, they become visible, a dramatic feature that changes our perception of our galactic home. Let your imagination paint this picture as you drift towards sleep. The Milky Way from the outside, a brilliant spiral of 200 billion stars, with a central bulge glowing warm and orange, and above and below, two enormous bubbles of hot gas rising into intergalactic space. At the very center of it all, too small to see but infinitely important, sits Sagittarius A, the anchor around which everything revolves. Now, let us consider something even more extraordinary. The light and radio waves we receive from Sagittarius A today left the galactic center 26,000 years ago. When those photons began their journey toward Earth, human beings were still living in the depths of the last ice age. Woolly mammoths roamed the northern continents, and our ancestors were painting the first great masterpieces on the walls of caves. This is one of the most amazing consequences of the finite speed of light. We never see the universe as it is right now. We only see it as it was at different times in the past, depending on how far away we are looking. The moon is about 1¼ light seconds away, so we see it as it was just over a second ago. The sun is about 8 light minutes away. The nearest star beyond the sun is about 4 light years away, and Sagittarius A star is 26,000 light years away, meaning we see it as it was when the Ice Age glaciers still covered much of North America. In some ways, this is a form of time travel. When we look at the galactic center, we are looking into the past. The black hole we observe has had 26,000 years to change since those photons left its vicinity. Perhaps a star has fallen too close and been torn apart. Perhaps a cloud of gas has drifted in and triggered a feeding frenzy. We would not know about any of this for another 26,000 years when the light from those events finally reaches us. This cosmic delay creates a kind of suspense that stretches across millennia. Whatever is happening at the galactic center right now will not be revealed to us until our distant descendants are around to witness it. And whatever our descendants learn about Sagittarius A star will be information about events that happened during our own lifetimes, events we could never know about while we were alive. Let that thought expand your sense of time as you settle into sleep. You are part of a chain that stretches from the past into the future, connected to ancestors who lived thousands of years. Argo and descendants will live thousands of years from now. The information flowing through the universe takes time to travel, and that time creates a web of connections that links different eras together. The photons arriving at Earth tonight from Sagittarius A star were emitted when humans were first learning to make fire with flint and tinder. The photons that will arrive 26,000 years from now will carry information about the galaxy as it exists today. As we continue our journey through the cosmos, let us pause to appreciate the scientists who have dedicated their lives to studying Sagittarius A star. Their work represents some of the finest achievements of human civilization, a testament to what we can accomplish when we combine curiosity with patience and technology. The story of discovering and understanding our galaxy's central black hole spans nearly a century, involving hundreds of researchers across dozens of countries. It began with early radio astronomers who noticed something peculiar in the direction of Sagittarius, and continues today with teams using the most advanced telescopes ever built. Each generation has added new pieces to the puzzle, building on the work of those who came before and laying foundations for those who will follow. Andrea Ghez, who shared the 2020 Nobel Prize for confirming the existence of Sagittarius A star, has spoken about the decades of work that led to her discovery. She and her team spent years developing better techniques for observing through Earth's turbulent atmosphere, gradually improving their ability to track the motions of stars near the galactic center. The process was painstaking, involving countless nights at the telescope and thousands of individual measurements, each one a tiny step toward understanding. Reinhard Genzel, who shared the Nobel with Ghez, led a parallel effort from Europe that independently confirmed the same conclusions. The fact that two separate teams, using different telescopes and different techniques, arrived at the same answer gives scientists great confidence that the result is correct. This is how science works at its best, with independent verification serving as a check against error and bias. The teams continue their work today, refining their measurements and pushing toward even more precise determinations of the black hole's properties. They have detected subtle effects predicted by general relativity including the precession of stellar orbits and the gravitational redshift of starlight as it climbs out of the black hole's gravitational well. Each new measurement is a test of Einstein's theories in conditions more extreme than anything we can create on Earth. In 2022, the Event Horizon Telescope collaboration released the first image of the shadow of Sagittarius A. This was an astonishing technical achievement, requiring a network of radio telescopes spanning the globe to work together as a single Earth-sized instrument. The resulting image shows a bright ring of glowing gas surrounding a dark center, exactly as theory predicted. It is the closest we have ever come to seeing a black hole directly, and it confirmed what decades of indirect evidence had already suggested. That image has joined the pantheon of iconic scientific photographs, alongside the first picture of Earth from space and the first glimpse of the Higgs boson in a particle detector. It represents a milestone in human understanding, a moment when something that had been purely theoretical became suddenly and beautifully real. You can look at that image and know that you are seeing the shadow of a supermassive black hole, the anchor at the center of your galactic home. Let the achievements of these scientists inspire a sense of gratitude as you prepare for sleep. We are fortunate to live in an era when so much has been discovered, when the mysteries of the cosmos are being solved at an unprecedented rate. Our understanding of the universe has expanded more in the past century than in all of previous human history, and that expansion continues every day as new observations are made and new theories are tested. You are the beneficiary of this scientific progress. The knowledge you have about Sagittarius A star, knowledge that would have seemed like magic to your great-grandparents, is now freely available to anyone curious enough to seek it out. The universe has been opened up to human understanding, and you are part of the generation that gets to appreciate these discoveries while they are still fresh and new. Now, let us return once more to the quiet darkness at the center of our galaxy, to the patient giant that has been waiting there for billions of years. As your body grows heavier and your mind grows lighter, picture Sagittarius A star as a place of profound stillness at the heart of cosmic motion. Everything around the black hole is moving. Stars race through space at millions of miles per hour. Gas clouds swirl and collapse and ignite into new stars. Magnetic fields twist and reconnect, releasing bursts of energy that propagate across light years. The entire galaxy rotates, completing one full turn every 250 million years, sweeping the spiral arms through space in a slow cosmic waltz. But at the very center, where Sagittarius A star resides, there is a kind of peace. The black hole itself does not move through the galaxy. It is the fixed point around which everything else revolves. It has no internal motion in the usual sense, no atoms vibrating or molecules tumbling. It is simply a region of curved space-time, a geometric feature of reality rather than a physical object in the ordinary meaning of the word. In that stillness, there is something almost meditative. The black hole does not strive or struggle. It does not compete or compare itself to other black holes. It simply exists, fulfilling its role in the cosmic order without effort or intention. There is a lesson there for those willing to learn, a reminder that sometimes the most powerful thing you can do is simply be present, holding your place in the universe while everything else moves around you. As you drift towards sleep tonight, imagine yourself settling into that kind of stillness. Let the thoughts that race through your mind be like stars orbiting a black hole, present but not needing your attention, following their own paths while you rest at the center. You do not need to chase your thoughts or push them away. You can simply let them be, observing them from a place of quiet awareness. The darkness behind your closed eyes is not unlike the darkness of Sagittarius A star. It is not an absence but a presence, a space where something profound exists even though it cannot be seen. In that darkness, you will find rest and renewal, the chance to process the day's experiences and prepare for whatever tomorrow brings. The cosmos will continue turning while you sleep. Stars will be born and stars will die. Light will travel across the vast distances of space, carrying information from one corner of the universe to another. The Milky Way will complete another tiny fraction of its 250 million year rotation, carrying you along as it orbits the supermassive black hole at its center. And when you wake, everything will still be there. The sun will rise, powered by nuclear fusion reactions that will continue for another 5 billion years. The stars will fade from view, overwhelmed by the light of day, but still present in the sky above. And Sagittarius A star will continue its patient vigil at the center of the galaxy, unmoved by your dreams or your waking thoughts, holding everything together with the same gravitational embrace it has maintained since long before Earth existed. This is the cosmic context of your life, the vast backdrop against which your small human story unfolds. You are a brief flicker of consciousness in an ancient and enduring universe, a momentary awareness that has the privilege of contemplating its own existence and the existence of everything around it. That privilege is rare and precious, a gift that deserves to be appreciated. So, as you settle into sleep, take a moment to appreciate the sheer improbability of your existence. Out of all the atoms in the universe, some of them came together to form you, a being capable of wondering about black holes and galaxies and the nature of spacetime. Out of all the possible arrangements of matter, one particular arrangement became aware of itself and began asking questions. You are the universe experiencing itself, a localized concentration of cosmic curiosity that will eventually disperse back into the endless flow of matter and energy. But that is a thought for another time. Right now, the only thing that matters is rest. Your body needs sleep to repair and restore itself. Your mind needs sleep to consolidate memories and process emotions. The work of being human is demanding, and you have earned this time of recovery. Let the gentle gravity of your pillow draw you down. Let the darkness of your closed eyes become the darkness of dreamless sleep, or the soft twilight of pleasant dreams. Whatever awaits you in the hours ahead, approach it with the same patient acceptance that Sagittarius A star brings to its role at the center of the galaxy. You do not need to control your dreams or direct your sleep. You can simply let go and trust that your body knows what it needs. The journey we have taken tonight has covered vast distances, from the warm comfort of your bed to the event horizon of a supermassive black hole and back again. We have explored questions that have puzzled humanity for centuries and touched on discoveries that are still being made today. We have found perspective in the face of cosmic immensity and belonging in the structure of our galactic home. Through it all, Sagittarius A star has remained our constant companion, the invisible giant at the center of every story we have told. It is the starting point and the ending point, the alpha and omega of our galaxy's existence. Without it, none of what we have discussed would be possible. With it, everything falls into place, orbiting in harmony around a common center. Let that harmony be the last thing on your mind as you drift into sleep. You are part of a system that works, a galaxy that has been functioning smoothly for billions of years. The same forces that keep planets in orbit around stars and stars, in orbit around black holes, are at work in your body right now, holding your cells together and keeping your heart beating in its steady rhythm. You are made of the same matter and governed by the same laws as everything else in the cosmos. You belong here in this universe, in this galaxy, in this moment. Sleep well, knowing that you are held by the gravity of Earth, held by the structure of the Milky Way, held by the patient presence of Sagittarius A star at the center of it all. Tomorrow will bring new challenges and new opportunities, but tonight there is only rest, only peace, only the gentle darkness that leads to renewal. The universe has a way of putting things in perspective. When you are caught up in the small concerns of daily life, when worries about work or relationships or health seem overwhelming, it can help to remember just how vast the cosmos truly is. Your problems are real and they matter, but they are also contained within a single mind, on a single planet, orbiting a single star, in the outer reaches of a single galaxy that is itself just one of trillions in the observable universe. This is not meant to minimize your experience. Your feelings are valid, your struggles are genuine, and the challenges you face deserve attention and effort. But there is a kind of freedom that comes from recognizing the cosmic context of your life, a lightening of the burden that happens when you see yourself as part of something much larger than any individual concern. Sagittarius. A star does not know about your worries. The black hole has no awareness, no judgment, no opinion about whether you are succeeding or failing at the tasks you have set for yourself. It simply exists, following the laws of physics, holding the galaxy together through the impersonal force of gravity. And yet, in that impersonality, there is a kind of comfort. The universe does not care about your mistakes because the universe does not care about anything. It simply is, and you are part of what it is. Let that thought release any tension you are still holding in your body. Unclench your jaw if it is tight. Let your shoulders drop away from your ears. Release the grip of your hands and allow your fingers to curl naturally. There is nothing you need to do right now, nothing you need to fix or solve or figure out. The universe will continue turning without your intervention, and you can rest. As we enter the final portion of our journey tonight, let us explore some of the most beautiful aspects of the galactic center, the visual wonders that would greet you if you could somehow travel there and see it with your own eyes. The galactic center is extraordinarily crowded with stars. In our neighborhood of the Milky Way, the nearest star to our sun is over 4 light years away. But near Sagittarius A star, stars can be separated by mere light weeks or even light days. Imagine a sky where the stars are so close together that they begin to overlap, where the Milky Way is not a band across the sky, but rather fills every direction you look with brilliant light. From a planet near the galactic center, you would never experience true night. The combined light of all those nearby stars would create a permanent twilight, a soft glow that illuminates everything without the harshness of direct sunlight. The sky would not appear black with scattered points of light, but rather a warm, golden expanse dotted with brighter and fainter regions, a 3-dimensional tapestry of stellar light extending in every direction. In that golden glow, you might be able to pick out some individual stars, particularly the brightest ones that burn hot and blue or swollen red. But most of the light would blend together, a continuous luminosity that ebbs and flows as you turn your gaze from one region to another. It would be utterly unlike anything we experience here in the quiet suburbs of the galaxy, a visual environment shaped by the extreme density of matter near the supermassive black hole. And somewhere in that glowing sky, if you knew where to look, you would find a region of absolute darkness. Not the darkness of empty space, but the darkness of a black hole that bends light around itself, creating a void in the stellar tapestry. That would be Sagittarius A star, visible not by its own light, but by the absence of light from everything behind it. A hole in the fabric of illumination, a patch of nothing surrounded by everything. The contrast would be striking. Light and darkness, presence and absence, the overwhelming fullness of stellar density, and the perfect emptiness of the event horizon. This is the paradox at the heart of our galaxy. The brightest and the darkest places in the Milky Way existing side by side, each defining the other through their opposition. Let your imagination rest in that contrast as you continue to relax. Light and darkness are not enemies. They are partners, each necessary for the other to exist. Without darkness, there could be no light, because light would have nothing to illuminate. Without light, there could be no darkness, because darkness would have nothing to contrast against. They arise together and define each other, a cosmic dance of opposites that creates the visual universe we experience. In your own life, you have probably noticed similar patterns: joy and sorrow, success and failure, connection and solitude. These apparent opposites are not separate things, but rather different aspects of the same experience, each giving meaning to the other. The black hole and the stars around it are like this: darkness and light intertwined in a relationship that has endured for billions of years. Now let us consider another remarkable feature of the galactic center: the intense magnetic fields that thread through the entire region. Magnetic fields are invisible to our eyes, but they exert powerful influences on charged particles and ionized gas, shaping the flow of matter in ways that can be traced by radio telescopes. Near Sagittarius A star, the magnetic fields are among the strongest in the galaxy. They form long filaments that stretch across light years, channeling plasma along their lines and resisting the compression of gravity. These fields interact with the supermassive black hole in complex ways, sometimes funneling material toward the event horizon, and sometimes deflecting it away. One of the most distinctive structures in the galactic center is called the radio arc, a series of long parallel filaments of magnetized gas that spans about 100 light years. These filaments are perpendicular to the plane of the galaxy, rising straight up from the galactic disk like the strings of a cosmic harp. Their origin and maintenance is still not fully understood, but they likely trace out the structure of the magnetic field in this region, revealing an invisible architecture that shapes the behavior of matter on enormous scales. The presence of these magnetic structures adds another layer of complexity to our understanding of the galactic center. It is not enough to think of this region as simply a collection of stars orbiting a black hole. We must also consider the magnetic forces, the flows of ionized gas, the radiation fields, and the gravitational tides that together create one of the most dynamic environments in the Milky Way. And yet, despite all this complexity, there is an underlying order. The stars follow predictable orbits determined by the laws of gravity. The magnetic fields obey the principles of electromagnetism. The radiation follows the rules of quantum mechanics. Everything in the galactic center, no matter how extreme or unusual, operates according to the same physical laws that govern the falling of a leaf or the beating of your heart. The universe is consistent in its rules, even when those rules produce wildly different outcomes in different environments. Let that consistency be a source of comfort. You live in an understandable universe, a cosmos that can be studied and explained and predicted. The same physics that allows us to build airplanes and computers and medical imaging devices also allows us to understand supermassive black holes 26,000 light-years away. Human intelligence, applied with patience and creativity, can unlock the secrets of even the most extreme environments in the cosmos. As you continue to drift towards sleep, let us spend a few moments considering the future of Sagittarius A star and the galaxy it anchors. We have talked about the past, the billions of years of history that have shaped our galactic home. But what lies ahead? What will the center of the Milky Way look like in the distant future? In the short term, cosmically speaking, things will remain much as they are now. Sagittarius, a star, will continue to quietly anchor the galaxy, occasionally flaring up when a cloud of gas or an unlucky star drifts too close. The S stars will continue their tight orbits, racing around the black hole in patterns that astronomers will track for decades to come. The circumnuclear disk will slowly feed material inward, and the central molecular zone will continue its sluggish star formation. But on longer timescales, dramatic changes are inevitable. As we discussed earlier, the Milky Way is on a collision course with the Andromeda Galaxy. In about 4 to 5 billion years, the two galaxies will begin to merge, their structures disrupted by gravitational tides as they pass through each other again and again. Over hundreds of millions of years, they will settle into a single larger galaxy, and their supermassive black holes will spiral toward each other until they merge. The merger of two supermassive black holes is one of the most violent events in the universe. As the two black holes orbit each other ever closer, they will accelerate to a significant fraction of the speed of light, distorting spacetime with their immense gravitational fields. In the final moments before merger, they will emit a burst of gravitational waves so powerful that it will briefly outshine all the electromagnetic radiation in the observable universe, though this emission will be invisible to our eyes and detectable only with sophisticated instruments. After the merger, the resulting black hole will be larger than either parent, containing the combined mass of both Sagittarius A star and its Andromeda counterpart. This new black hole will settle at the center of the merged galaxy, establishing a new anchor around which all the stars of Milkdromeda will orbit. But even this is not the end of the story. On even longer timescales, hundreds of billions to trillions of years in the future, the galaxy itself will fade as its fuel for star formation is exhausted. Stars will continue to die without new ones being born to replace them. The galaxy will grow dimmer and dimmer, its light slowly extinguished as the last stellar furnaces burn out. Eventually, in the unimaginably distant future, even the longest-lived stars will have run out of fuel. The galaxy will be populated only by stellar remnants, white dwarfs and neutron stars and black holes, slowly cooling and fading in the eternal darkness. The supermassive black hole at the center will remain, still anchoring the dim remnants of its host galaxy, but there will be no starlight to illuminate its shadow. And then, on timescales so long that our current mathematical notation struggles to express them, even the black holes will evaporate through Hawking radiation. Sagittarius, a star which has endured for so many billions of years, will slowly shrink as it emits the faintest possible radiation, losing mass imperceptibly over trillions upon trillions of years. Eventually, after a span of time that makes the current age of the universe seem like the blink of an eye, even this great anchor will dissolve into a spray of particles and radiation, leaving nothing behind. This is the ultimate fate of our galactic center. the eventual endpoint of the cosmic story we have been telling tonight. It is a future so distant that it barely seems real, a thought experiment more than a prediction. And yet, the physics that leads to this conclusion is solid. Black holes evaporate, matter decays. Nothing lasts forever in the physical universe. But do not let this distant future trouble your dreams tonight. You will not be there to witness the death of stars or the evaporation of black holes. Your concern is with the here and now, with the next few hours of restful sleep and the day that will follow when you wake. The cosmos will take care of itself over the eons to come. Your job is simply to rest and renew yourself for the small portion of cosmic time that belongs to you. Let the vastness of cosmic time put your own time into perspective. You have perhaps 80 or 90 years on this planet, a vanishingly small fraction of the age of the universe. But those years are your years, the only ones you will ever have, and they are worth living fully and well. The fact that you are temporary does not make you less meaningful. It makes you precious, a rare and fleeting phenomenon in a universe mostly composed of empty space and simple matter. You are a configuration of atoms that knows it exists. You are a pattern of matter that can contemplate its own pattern. You are a local concentration of complexity in a cosmos that tends toward disorder. These are remarkable facts, and they should fill you with a sense of wonder rather than anxiety about your eventual dissolution. Now, as we approach the final stages of our journey together, let us return to the simple act of breathing. Your breath connects you to the atmosphere of Earth, which connects you to the sun that powers our planet's weather systems, which connects you to the galaxy that formed the sun from the remnants of earlier stars. Each inhale draws in atoms that have circled Sagittarius A star for billions of years. Each exhale returns those atoms to the cosmic cycle, eventually to be incorporated into new stars, new planets, perhaps new forms of life. Breathe in slowly and feel your chest expand. Notice how your body knows exactly what to do, how your lungs inflate without any conscious effort on your part. This automatic process has been keeping you alive since the moment of your birth, and it will continue without interruption while you sleep. You can trust your body to breathe for you while your conscious mind takes its rest. Breathe out slowly and feel your body release. Let any remaining tension flow out with your breath, dissolving into the atmosphere and dispersing into the infinite ocean of air that surrounds our planet. There is nothing to hold on to, nothing to grip or grasp. Simply let go, as you have let go at the end of every day since you were born. The rhythm of your breath is like the rhythm of the cosmos itself, an endless cycle of expansion and contraction, of gathering and releasing. The universe began with a great expansion and has been expanding ever since. Stars gather matter through gravity and then release it through supernova explosions. Galaxies form and evolve and eventually fade. Everything participates in this cosmic breathing, this eternal rhythm of becoming and unbecoming. You are part of that rhythm tonight. As you breathe in, you are gathering the peace and rest your body needs. As you breathe out, you are releasing the cares and concerns of the waking day. This is natural. This is right. This is what your body was designed to do. Let us take a few more breaths together, syncing our rhythm with the slow turning of the galaxy far above. Breathe in deeply, filling your lungs with the air of Earth, air that has been circulating on this planet for billions of years. Hold for just a moment, feeling the fullness of the breath, the potential energy waiting to be released, and breathe out completely, emptying your lungs and making room for the next cycle to begin. As you continue this gentle breathing, feel your body growing heavier and more relaxed. The muscles of your face are softening. Your jaw is slack. Your eyelids are heavy and still. The muscles of your neck and shoulders are releasing their grip, allowing your head to sink more deeply into your pillow. Your arms are heavy at your sides. Your legs are heavy on the mattress. Your whole body is surrendering to the gentle pull of gravity. This is the same gravity that holds the stars in their orbits around Sagittarius A. This is the same force that keeps the moon circling Earth and Earth circling the sun. Gravity is the great connector, the invisible thread that ties everything in the universe together. And right now, gravity is gently drawing you down into sleep, pulling your body toward rest with the same patient insistence that it pulls planets toward stars and stars toward black holes. Trust in that pull. Let gravity do its work. You do not need to fight against the heaviness that is spreading through your limbs. You do not need to resist the drowsiness that is clouding your thoughts. These are signs that your body is doing exactly what it needs to do, preparing itself for the deep restoration of sleep. In the coming hours, while you rest, your body will be busy with important work. Cells will be repaired and replaced. Memories will be consolidated and organized. Hormones will be released that regulate everything from your immune system to your emotional well-being. Sleep is not a passive state, but an active process of renewal, a complex choreography of biological systems working together to keep you healthy and functional. And while all of this is happening in your body, the cosmos will continue its own endless choreography. The Earth will rotate, carrying you from night into day. The moon will inch a tiny bit farther along its orbit. The sun will burn through millions of tons of hydrogen every second, converting mass into the energy that will warm your face when you wake. And far away, at the center of the galaxy, Sagittarius A will continue its eternal vigil, holding everything together in the darkness. You are connected to all of this. Whether you are awake or asleep, conscious or dreaming, the atoms in your body are the same atoms that form the stars. The forces that govern your cells are the same forces that govern galaxies. You are not separate from the cosmos. You are an expression of it, a localized concentration of universal matter and energy that has temporarily taken the form of a human being. Let that sense of connection accompany you into sleep. You are not alone in the darkness of your bedroom. You are surrounded by a universe that has been your home for the entire history of your existence. Every photon of light that has ever touched your eyes began its journey in a star. Every atom of oxygen in your lungs was forged in a stellar furnace. You are made of stars, and to the stars you will eventually return. But that return is far in the future. Right now, you are here, in this moment, in this bed, in this body, preparing for sleep. The cosmic journey will wait for you. The stars will still be there when you wake, and Sagittarius A will still be anchoring the galaxy. Everything will continue in your absence, and everything will be there to greet you when you open your eyes. Rest now. Let the darkness of sleep wrap around you like the darkness of space wraps around distant stars. Let your thoughts scatter like photons into the void, dispersing and fading and eventually dissolving into the peaceful emptiness of dreamless rest. There is nothing to fear in this darkness, nothing to worry about, nothing to solve or fix or understand. The black hole at the center of our galaxy does not struggle against its nature. It does not wish it were something other than what it is. It simply exists, following the laws of physics, holding space and time in its gravitational embrace. You can be like that black hole tonight, simply existing, simply resting, simply being what you are without effort or striving. Let Sagittarius A star be your model for perfect stillness. At the center of all the cosmic motion, at the heart of the swirling galaxy, there is a point of absolute calm. You can find that point within yourself, the still center around which all your thoughts and feelings orbit. You can rest there tonight, at the center of your own inner universe, while everything else moves and changes around you. The journey we have taken together is almost complete. We have traveled 26,000 light years to the heart of the Milky Way. We have explored the nature of supermassive black holes, the orbits of stars in extreme environments, and the vast structures that surround the galactic center. We have contemplated the past, present, and future of our cosmic home, and we have found perspective in the face of overwhelming immensity. But more than any of that, we have found peace. We have found a way to think about the universe that brings comfort rather than anxiety, wonder rather than fear. We have found our place in the cosmic order, orbiting the same center as every other star in the galaxy, connected to everything through the invisible threads of gravity and history. Take that peace with you into sleep. Let it wrap around you like a warm blanket, insulating you from the cares of the waking world. Let it fill your dreams with gentle images of stars and galaxies, of vast distances and eternal patience. Let it remind you, whenever you feel lost or alone, that you are part of something infinitely larger than yourself, a cosmos that has been your home from the moment of your birth, and will continue to be your home long after you are gone. Sagittarius, a star will be waiting for you whenever you want to return. The invisible giant at the center of our galaxy is always there, always patient, always holding everything together. You can visit it in your imagination whenever you need to find perspective, whenever the concerns of daily life threaten to overwhelm you, whenever you want to remember just how small your problems are compared to the vastness of the universe. For now, though, it is time to sleep. Your body is ready, your mind is quiet, and the night is deep and welcoming. Let yourself sink into the mattress. Let yourself dissolve into the darkness. Let yourself become one with the peaceful stillness of the sleeping world. The stars are watching over you, even if you cannot see them through your ceiling. Somewhere above you, the Milky Way stretches across the sky, a river of light pointing toward the galactic center. And at the end of that river, invisible but present, Sagittarius A star waits with infinite patience, the anchor at the center of your cosmic home. Sleep well, traveler. May your dreams be gentle, and may you wake refreshed and renewed, ready to face another day in this beautiful, mysterious universe we share. The gentle hum of the cosmos continues even as your conscious mind begins to fade. Think of it as a lullaby written in the language of physics, a song that has been playing since the beginning of time and will continue playing long after the last star has faded. You are a brief audience for this eternal music, privileged to hear it during your short time in the universe. Every civilization that has ever existed on any planet in the Milky Way has shared this same cosmic home. They have all orbited the same supermassive black hole, whether they knew it or not. Some of them may have developed the science to understand their galactic address, while others may have lived and died without ever suspecting what lay at the center of the night sky. But all of them were part of the same spinning cosmic carousel, all of them held in place by the same gravitational anchor. You are one of the lucky ones. You live in an era when the nature of Sagittarius A star has been revealed, when the mysteries of black holes have been at least partially solved, when telescopes can peer across 26,000 light years and detect the dance of stars around an invisible giant. You know things about the universe that would have seemed like magic to your ancestors, and you carry that knowledge with you into sleep. What a privilege it is to be alive in this moment, to be aware of the cosmic context of your existence, to understand even a fraction of the vast machinery that makes the universe work. Not everyone has this opportunity. For most of human history, people looked up at the stars with wonder but without comprehension, seeing patterns in the sky without understanding the fires that created those lights or the distances that separated them. You live in a different world, a world illuminated by science, a world where the mysteries of the cosmos are being solved one by one. And yet, for all our progress, there is still so much we do not know. The universe keeps revealing new puzzles, new questions, new depths of complexity that challenge our understanding. This is not frustrating but exhilarating, a promise that future generations will continue to make discoveries, will continue to push back the boundaries of the unknown. Perhaps someday, centuries or millennia from now, human beings will actually travel to the galactic center. Perhaps they will build spacecraft capable of crossing the vast distances between stars, carrying explorers who will see Sagittarius A star with their own eyes. Perhaps they will hover near the event horizon and watch the strange distortions of spacetime that occur in such extreme gravitational environments. Perhaps they will return home with stories that make our current knowledge seem primitive and incomplete. But even if that day comes, the essential nature of Sagittarius A star will remain the same. It will still be a concentration of matter so dense that nothing can escape its gravitational pull. It will still be the anchor at the center of our galaxy, holding everything in place with the patient hand of gravity. It will still be the quiet giant that has witnessed the entire history of the Milky Way, and will witness its eventual transformation into something new. Some truths are permanent, even in a universe of constant change. The laws of physics are among these permanent truths, the underlying rules that govern every interaction from the smallest quantum fluctuation to the largest galactic collision. Gravity always attracts. Light always travels at the same speed. Matter and energy are always conserved. These principles have been true since the universe began, and they will remain true until the universe ends. You can trust in these principles as you drift towards sleep. The same physics that keeps you on your bed will keep working while you rest. The same atoms that make up your body will continue following their quantum rules. The same forces that hold molecules together will maintain the structure of your cells. Nothing fundamental will change during the night. You will wake up in the same universe you fell asleep in, governed by the same laws, illuminated by the same stars. This consistency is the bedrock of reality, the stable foundation on which everything else is built. Without it, science would be impossible. Technology would be impossible. Life itself would be impossible. The fact that the universe plays by consistent rules is the single most important fact about existence, the truth that makes all other truths possible. Sagittarius, a star, exists because of these rules. The black hole did not choose to form. It did not decide to anchor the galaxy. It simply emerged as the natural consequence of matter, concentrating under the influence of gravity, following the script written into the fabric of spacetime by the fundamental laws of physics. Everything we have discussed tonight, from the orbits of the S stars to the emission of gravitational waves, follows inevitably from these basic principles. There is something deeply reassuring about this inevitability. The universe is not arbitrary or capricious. It does not make random decisions or change its mind without warning. It follows rules, and those rules can be discovered and understood by creatures like us who have evolved the capacity for abstract thought. The black hole at the center of our galaxy is not a mystery in the deepest sense. It is a consequence, a natural outcome of the way the universe works. You are also a consequence of the way the universe works. The atoms in your body were forged in stars. The molecules that make up your cells assembled themselves according to the laws of chemistry. The neurons in your brain fire according to the principles of electrochemistry and information theory. Everything about you, from your heartbeat to your dreams, is the result of physical processes following physical laws. This does not make you less special. If anything, it makes you more special. A reminder that the universe has the capacity to produce beings like you through nothing more than the consistent application of its fundamental rules. Out of hydrogen and helium, out of gravity and electromagnetism, out of billions of years of cosmic evolution, you emerged. That is a miracle, even if it is a miracle that can be explained by science. As you settle deeper into sleep, let your mind release any remaining thoughts. They will be there when you wake, waiting to be picked up and examined in the light of a new day. For now, they can rest alongside you, inactive and quiet, stored in the neural networks of your brain until you need them again. The darkness of sleep is not empty. It is full of potential, full of the raw material from which dreams are made and memories are consolidated. In that darkness, your brain will sort through the experiences of the day, deciding what to keep and what to discard, strengthening some connections and weakening others. This process is essential for learning and growth, and it happens entirely outside your conscious awareness. Trust in this process. Your brain knows how to sleep. It has been doing this every night since before you were born, through all the stages of human development from infant to adult. You do not need to supervise or control what happens during sleep. You can simply let go and allow your brain to do its work, confident that you will wake up feeling better than when you went to bed. The same trust can be extended to the cosmos. The universe knows how to be a universe. It has been doing this for nearly 14 billion years, and it will continue for billions more. The stars know how to burn, the planets know how to orbit, and the black holes know how to anchor galaxies. Everything is functioning according to plan. If a plan is even the right word for something as impersonal and automatic as physical law. Sagittarius. A star does not need your attention or your worry. It will be fine without you monitoring it. The galaxy will continue spinning, the stars will continue orbiting, and the great cosmic dance will proceed whether you are awake to watch it or not. This is liberating, a release from any sense of cosmic responsibility. You are not responsible for maintaining the universe. You are only responsible for yourself. And right now, that means getting a good night's sleep. Let this final thought carry you over the threshold into true rest. The universe is vast and ancient and largely indifferent to human concerns. But within that vastness, there is a place for you. You belong to the Milky Way galaxy. You orbit Sagittarius A star. You are made of matter that has been cycling through cosmic systems for billions of years, and you will return to that cycle when your time is done. In the meantime, you have tonight. You have this bed, this pillow, this warm cocoon of blankets protecting you from the cold outside. You have the darkness of your closed eyes and the silence of the sleeping house. You have everything you need to rest and recover, to dream and be renewed. The invisible giant at the center of our galaxy is holding you in its gravitational embrace, along with every other atom in the Milky Way. You are part of a system that has been functioning smoothly for more than 13 billion years. You can trust in that system. You can rest in that system. You can let go and allow the gentle forces of the cosmos to carry you through the night. Your eyelids are so heavy now. Your breathing has slowed to a deep and regular rhythm. Your thoughts are scattered and hazy, no longer forming coherent sentences, but rather dissolving into impressions and feelings. This is the edge of sleep, the liminal space between waking and dreaming, and you are ready to cross over. Do not resist. Do not try to hold on to consciousness. Let it slip away like water through your fingers, flowing naturally toward the peaceful depths of sleep. The universe will still be there when you return. The stars will still be shining. Sagittarius, a star will still be waiting at the center of it all, patient and eternal and utterly unmoved by the passage of time. Tomorrow you will wake to a new day, full of its own challenges and opportunities. But that is tomorrow's concern. Right now, in this moment, there is only rest. There is only peace. There is only the gentle darkness wrapping around you like the darkness of space wrapping around the brightest stars. You have traveled far tonight, from your bed to the heart of the galaxy and back again. You have learned about supermassive black holes and stellar orbits, about gravitational waves and the information paradox, about the Fermi bubbles and the circumnuclear disk. You have contemplated distances so vast, they strain the imagination, and timescales so long, they make human history seem like a single breath. And through all of it, you have remained safe in your bed, your body warm and comfortable, your mind free to wander through the cosmos without any physical danger. This is the magic of imagination, the ability to travel anywhere and experience anything without ever leaving home. You have used this magic tonight to visit one of the most extreme environments in the known universe, and you have returned with a deeper appreciation for your place in the cosmic order. That appreciation is now woven into the fabric of your mind, available whenever you need it. The next time you feel small or insignificant, remember Sagittarius A star. Remember that you are orbiting the center of a galaxy containing hundreds of billions of stars. Remember that the atoms in your body have been traveling through space for billions of years, participating in cosmic processes that dwarf anything human beings have ever built. Remember that you are a child of the universe, born from the same primordial matter that formed the first stars. These are not just facts. They are sources of comfort and perspective, available to you whenever the pressures of daily life threaten to overwhelm. The cosmos is always there, waiting to put your troubles in context. The black hole at the center of our galaxy is always there, holding everything together with the same patient gravity it has maintained since long before Earth existed. You are connected to all of it. You always have been and you always will be, for as long as you exist. Even after your individual consciousness fades, the matter that made you will continue its cosmic journey, incorporated into new stars and new planets, and perhaps new forms of life. Nothing is truly lost in the universe. Everything is recycled and transformed, passed from one configuration to another in an endless dance of becoming. But that is a thought for another time. Right now, the only thing that matters is rest. Your body needs sleep to repair and regenerate. Your mind needs sleep to process and consolidate. The work of being human is demanding, and you have earned this time of recovery. Let the galaxy spin without you for a few hours. Let the stars continue their orbits while you rest. Let Sagittarius A star maintain its patient vigil at the center of it all, asking nothing of you, expecting nothing, simply existing as it has for billions of years and will continue for billions more. You have done enough for today. You have been awake and aware and engaged with the challenges of existence. Now it is time to surrender, to let go, to trust in the darkness that leads to renewal. The night is kind, and sleep is its gift to those who are willing to receive it. Accept that gift now. Let your final waking thoughts dissolve into the peaceful emptiness of rest. Let your body sink into the mattress, your muscles releasing their tension, your breathing becoming slow and deep and regular. Let everything else fall away, leaving only the simple truth of this moment, here, now, resting in the darkness. The journey to Sagittarius A has ended, but the journey of your life continues. Tomorrow will bring new experiences, new challenges, new opportunities for growth and connection. But first, you must rest. First, you must sleep. First, you must allow the night to work its gentle magic on your body and mind. Good night, traveler. May the stars watch over you, and may you wake to find that the universe is still exactly as you left it, vast and beautiful and full of wonder. May you carry the peace of tonight's journey with you into the waking day, a calm center around which your thoughts and feelings can orbit. May you remember, whenever you need to, that you are part of something infinitely larger than yourself, a cosmos that has been your home from the very beginning. The invisible giant waits for you at the center of the galaxy, patient and eternal, holding everything together in the darkness. And you, here in your bed, are part of that everything, connected by gravity and history and the fundamental laws that govern all of existence. You belong to this universe, and this universe, in its own indifferent way, belongs to you. Sleep now, rest deeply, dream of stars and galaxies, of vast distances and eternal patience, of the quiet anchor at the heart of our spinning cosmic home. And when you wake, may you find that the peace of the cosmos has settled into your bones, a calm that carries you through whatever the day may bring. Good night. As the last echoes of waking thought fade from your mind, consider one more beautiful truth about the cosmos we call home. The very ability you have to contemplate Sagittarius A, to imagine traveling 26,000 light years through space, to understand what a black hole is and how it shapes the galaxy around it. This ability itself is a cosmic miracle. The universe spent nearly 14 billion years preparing for this moment. First, there had to be a universe at all, a burst of energy from nothing that we call the Big Bang. Then there had to be the formation of the first atoms, hydrogen and helium condensing from the primordial plasma. Then the first stars had to form, gathering that hydrogen and fusing it into heavier elements. Then those stars had to explode, scattering their enriched ashes across space. Then new stars had to form from those ashes, and around some of those stars, planets had to coalesce from the debris. On at least one of those planets, the conditions had to be just right for chemistry to become biology. Simple molecules had to combine into more complex ones, eventually producing structures capable of reproducing themselves. Those self-replicating structures had to evolve over billions of years, becoming ever more complex, developing nervous systems, and eventually brains capable of abstract thought. And then, only recently in cosmic terms, some of those brains had to develop science, the systematic study of the natural world through observation and experiment. They had to build telescopes and spectrometers and radio antennas. They had to develop mathematics sophisticated enough to describe curved space-time and gravitational physics. They had to accumulate enough knowledge, generation after generation, to finally understand what sits at the center of their galaxy. You are the inheritor of all that history. Every step along the way, from the Big Bang to this very moment, was necessary for you to be lying here thinking about Sagittarius A. If any link in that chain had been broken, if any crucial event had failed to occur, you would not exist. The universe had to unfold in exactly the way it did for there to be a you, here, now, contemplating the invisible giant at the heart of the Milky Way. This is sometimes called the anthropic principle, the observation that the universe must have certain properties in order to produce observers who can contemplate those properties. It is a tautology in some ways, since of course we can only exist in a universe capable of producing us. But there is still something profound about recognizing just how many conditions had to be met, just how many cosmic accidents had to occur in just the right sequence, for conscious beings to emerge and begin asking questions about their origins. You are the universe asking questions about itself. You are matter that has organized itself into a pattern capable of wondering where it came from and where it is going. You are the cosmos looking back at its own structure, marveling at what it sees. This is not a small thing. This is perhaps the most remarkable thing that has ever happened in the entire 14 billion year history of existence. And it is happening right now in your tired mind as you drift towards sleep. Even as your thoughts become fuzzy and your awareness dims, you remain a node of cosmic self-reflection at a place where the universe is conscious of itself. That consciousness will fade as you sleep, retreating into the background hum of neural activity that continues even in the deepest stages of rest. But it will return when you wake, ready to contemplate the cosmos once more. The stars do not know they are being watched. The black hole at the center of our galaxy has no idea that creatures on a small planet 26,000 light-years away have deduced its existence and measured its mass. The universe, in its vastness and impersonality, is utterly unaware of the awareness that has emerged within it. And yet, that awareness exists, and its existence changes everything. Without conscious observers, the universe would still be vast and ancient and full of wonders. But those wonders would go unappreciated. The beauty of a spiral galaxy would exist without anyone to find it beautiful. The elegance of gravitational physics would exist without anyone to find it elegant. The universe would be like a symphony played in an empty concert hall, all the notes sounding, but no one there to hear. You are part of the audience for this cosmic symphony. Your presence matters, not because the universe needs you, but because without beings like you, the symphony would have no meaning. Meaning is something that conscious minds bring to the cosmos, a layer of significance that we paint onto the raw facts of physical existence. The black hole does not know it is anchoring a galaxy, but you know, and your knowing is itself a cosmic event. Let that thought accompany you into sleep. You are not just a passive observer of the universe. You are an active participant in the creation of meaning, a node in the network of conscious beings who are collectively trying to understand where we came from and where we are going. Every thought you have about Sagittarius A, every moment of wonder you experience when contemplating the cosmos, adds to the sum total of meaning in the universe. That meaning will persist after you are gone, passed along through the accumulated knowledge of human civilization. The things we have learned about the Galactic Center will be taught to future generations, who will build on that knowledge and learn even more. The understanding you have gained tonight, however small, is part of a larger project that spans centuries and will continue for as long as curious beings exist to ask questions. You are a link in that chain, a temporary holder of cosmic knowledge that was passed to you from those who came before and will be passed on to those who come after. This is a kind of immortality, not of the individual, but of the species, a continuity of understanding that transcends any single life. The scientists who first detected radio waves from Sagittarius A star have mostly passed away, but their discoveries live on. The knowledge they gained is now part of you, and it will continue to propagate into the future. Rest now, knowing that you carry within you the accumulated wisdom of generations. The questions you ask about the cosmos are the same questions humans have always asked, updated with new knowledge and new techniques, but fundamentally unchanged. Where did we come from? What is our place in the grand scheme of things? What lies at the center of the night sky? These are the eternal questions, and you have spent tonight exploring one possible set of answers. There are other answers, of course. There are other ways of thinking about our relationship to the cosmos, other frameworks for understanding what it means to be a conscious being in an unconscious universe. Science does not have a monopoly on meaning, and the perspective we have explored tonight is just one of many that humans have developed over the millennia. But it is a powerful perspective, grounded in observation and tested against reality, and it offers its own kind of comfort to those who embrace it. The comfort comes from understanding. When you know what Sagittarius A star is and how it shapes the galaxy around it, the center of the Milky Way becomes less mysterious and more beautiful. Mystery has its own appeal, but so does comprehension. There is a deep satisfaction in grasping how something works, in fitting a piece into the puzzle of existence, in feeling the click of understanding as a new concept falls into place. You have experienced that satisfaction tonight, learning about black holes and stellar orbits and the structure of our galactic home. That knowledge is now part of you, woven into the neural networks of your brain, ready to be accessed whenever you need it. Tomorrow or next week or next year, you might look up at the night sky and remember what you learned tonight. You might see the band of the Milky Way and think about the invisible giant at its center. You might feel a moment of cosmic connection, a sense of belonging to something vast and ancient and beautiful. That connection is available to you whenever you want it. The cosmos is always there, waiting to provide perspective and wonder. Sagittarius, a star is always there, holding the galaxy together, asking nothing from you, but offering everything in return. You can revisit these ideas as often as you like, each time discovering new depths and new implications, each time feeling a little more connected to the universe that produced you. But for now, the time for thinking has passed. The time for contemplation and wonder and cosmic perspective has given way to the time for rest. Your body is calling you towards sleep, and you should answer that call. The thoughts will still be there when you wake. The black hole will still be there at the center of the galaxy. Everything will wait for you while you rest. Close your eyes one final time. Feel the weight of your body pressing into the mattress. Notice the gentle rise and fall of your chest as you breathe. Let any remaining thoughts float away like clouds drifting across a night sky. There is nothing left to do, nothing left to think, nothing left but the sweet surrender of sleep. The galaxy turns, the stars orbit, the black hole waits, and you, here in your small corner of the cosmos, rest peacefully through the night, cradled by gravity, connected to everything, part of the eternal dance of matter and energy that makes up the universe we call home. Good night, child of the Milky Way. Sleep well and dream of stars. The silence of space extends in every direction from where we float together in imagination, a perfect stillness that contains multitudes. Within that silence, unimaginable energies are being released, stars are being born and dying, galaxies are colliding and merging. But from a distance, it all appears peaceful, a slow cosmic ballet performed across timescales that make human life seem like the flash of a firefly. This peacefulness is your inheritance, the calm at the heart of chaos, the stillness at the center of motion. Sagittarius A star embodies this paradox perfectly, the most violent gravitational environment in the galaxy existing as a point of absolute stability. Everything else may spin and change and transform, but the black hole remains, anchoring it all with serene indifference. You can carry that serenity with you into sleep. You can let it settle into your bones and quiet your restless mind. The cosmos has been at peace with itself for billions of years, despite all its violence and transformation. You can be at peace too, despite whatever storms may be raging in your life. The trick is to find your center, the still point around which everything else can orbit without disturbing your fundamental calm. Tonight, let Sagittarius A star be your guide to that center. Let its example teach you the art of patient endurance. Let its gravity remind you that sometimes the strongest forces are invisible, working quietly beneath the surface of things. Let its darkness show you that there is nothing to fear in the void, only mystery and wonder and the endless potential for discovery. The night deepens around you. The stars wheel overhead in their ancient patterns. Somewhere beyond the reach of your senses, the supermassive black hole continues its vigil at the center of the galaxy, as it has for billions of years and will for billions more. You are part of this cosmic tapestry, woven into it by gravity and time and the shared history of all matter since the beginning of the universe. Rest in that belonging. Let sleep take you gently into its arms. And know that when you wake, the universe will still be here, vast and beautiful, waiting to share its wonders with anyone curious enough to look. Good night.